which basically is a podcasting website, but I find it pretty easy just to use a device here that easily shares to this, that easily projects here, and easily records to YouTube. So here we are. Welcome back. Officially, our lesson. Where's my notes, which are all over the place?
No, I just think you're all over the place.
You'll find that out. If you haven't already figured that out, you will find that out really fast. At the same time, I know exactly what's going on. So we begin our journey with function. How's that? Can everyone see that? Is that okay? Yeah, good. So anyone remember anything about what a mathematical function is from a previous course? Maybe even just coming in?
Yeah, that you plug something in to get a certain result.
Yep. So you plug something in and you get a certain result. Perfect. Anyone else want to add to that? Build off of that?
Each input has its own individual output.
Getting much warmer to a math textbook definition of what a function is. Every input has, I like the word you said that, what was it? Individual output. Very good. Anyone else want to chime in? Yeah.
When an input has only one output?
So when an input has only one output, again, I know what that means. So for everybody, a function is so in this course, we're going to say it's a relationship between two quantities, but if you take calculus 3, which many of you will, and you work in three-dimensional space, it could be 3 quantities, it could be 4 quantities. Computer scientists will take a lot of different inputs, like 20 inputs, and then pair it with something. But for us, it's going to be a relationship between two quantities. The first where, oops, let me clean that up. So it's a relationship between two quantities, two quantities, that would be important, where the element, so basically number, but I'll briefly explain in a minute why we use the word element, but where the number from the input set, what's the input set called? If you scoop up all the inputs, starts with a D, ends with a main. Domain. Pairs with exactly one element in the output set called the what? Range. Cool. All right, so officially our first definition or a reminder of what a function is. And most of our course is the study of a lot of functions. So review of lines, quadratics, if you remember that, polynomials, exponentials, logarithms, sine, cosine, tangent, their reciprocals, inverse functions, and then we look at non-functions. So ellipse, hyperbolas, circles, and then we look at linear algebra stuff and how they can be functions and not functions, matrices, determinants, and that's kind of our course in a nutshell. 28, not even 28 lessons, we got to get through all that. Functions, when we take one object from a domain, and it pairs with exactly one object from a range. Sometimes we draw these little diagrams called mappings. So it's like, I like to think of them as like little islands. So island, that's our input island. Another island, output island, called the range. So if this is our domain, we have all these little people. It's like, hey, and then over here they pair with something. So as long as like this pairs with one thing, this pairs with that, maybe this is that, maybe this is like, I don't know, whatever. This is a function. Actually, we just have to make sure. That's still a function. So this input pairs with one object over here. This input right here pairs with one object over there. It's the same object. It could be like, here's me, here's my brother, and we both have the same mom. So that's still an object. You would say Matt is the input. Pair it with the birth mother, Jessica. And then this person right here, my brother Tom, that's the input. Pair it with their birth mother, Jessica. So this is still a function. Obviously, everyone else has clear like one paths, all in all. But not a function would be something like this. Here's some people. And come on, highlighter, let's go. There we go. A little bit off there. This might not be as elegant as I thought. Here's our issue. That's like saying, all right, who's your birth mother? 2. Now, it's year 2025. That might be possible, but I'm not quite sure. Well, it definitely would break the definition of a function anyways. So if you have like one input and you think there's 2 outputs, not a function. Another silly analogy that I'll make a million analogies in this course. It's like a vending machine, right? So you input this button and 2 pieces of candy fall out. It's a great day for you, but the machine's not functioning, right? So vending machine, this button gives you Coca-Cola. This button gives you Coca-Cola. That's functioning. This button gives you Sprite. This button gives you Diet. This one gives you orange, whatever, right? So every input has one output. This button gives you Coke. This button gives you Coke and Diet Coke. It's not functioning, all right? So every input can only have one output, not a function. Have you learned that before?
Mhm.
Cool.
Like with the vertical line test.
Vertical line test. That's coming up real soon. I swear I made this more pages, but all right. I want a lot more pages. All right. So we'll consistently throughout this course, as I said, we have a lot of functions to go through and non-functions eventually. So this idea of domain does not just end tonight, but it starts right now. So this is something that will start now and end on the day of the final exam. But if you're taking another calc course, you'll definitely talk about domain a lot. So the domain of a function, well, here's an example. Mentally evaluate the function f at at 2, at 3, and at 4. What's f of 2?
-1.
-1?
Yep.
Anyone not sure what it is? Not going to raise their hand if we're not sure. Yeah, all good. So this is what we call function notation. It really is just standing for output. So it's like, hey, here's an output. And this is the recipe for getting your output. You take 1 and you divide it by your input minus 3. So output, what's the recipe for output? 1 divided by input minus 3. And so this specific question is saying, all right, go to that function, input 2. So, okay, 1 divided by 2 minus 3. 2 minus 3 is -1. 1 divided by -1 is -1. So I'll put that in its glory. F of 2 is 1 over 2 minus 3, which is -1, which means this rule now says not Matt pairs with Jessica, not Tom pairs with Jessica, but it says 2 as an input pairs with -1. This input pairs with that output. What about f of 4? Same idea. F of 4 means 1 over 4 minus 3. 4 minus 3 is 1, and this simplifies to 1. Why did I skip this guy?
It doesn't exist.
Doesn't exist. I'm going to say the same thing. Yeah, so 1 over, 3 minus 3 would be 1 over 0, and that is undefined. So we learned something right here about the domain of the function. It turns out 3 would be excluded from the domain. Inputs that don't pair with something are not in the domain. You have to pair with something. That's why when I drew that mapping a few minutes ago, I was like, oh, make sure. I had a couple, remember, like I drew it quickly and I was like, oh, I got to make sure these pair with something because I'd be lying to you. Everything in the domain has to pair with something, otherwise it's not there. And undefined is not a pairing. It's you might think it pairs with undefined, but no, it doesn't. Leave it that. No, right? So if you get undefined, it's not in the domain. How would we write the domain of this? Oh, by the way, so while I'm here, would there be anything else that would cause this to be dividing by 0? No, right? So I think you just need that common sense. And if you're confident that so far you're in the right spot, we're still not in the fire zone, but we're about to be, right? So you should be able to look at this and just instinctively say, the only number that's going to cause this to be dividing by 3, what number minus 3 makes 0 is 3. We would write this domain in something called interval notation as follows.
Negative infinity, 3 in union with 3.
Here's your tutor when you need someone, you need a study group, how much you charge? Negotiable. Nothing less than 75. No, all right, so domain, this is called interval notation. I'm not teaching interval notation. If you need a review on it, it is something that you need a review on, and add that to your note right now. Watch a YouTube video, a Khan Academy video, get a tutor, reach out to me individually, but it's something that you, I promise, can pick up really, really quick. You're supposed to have exposure to that. I'll quickly just say, this is saying start at negative infinity. That's like a concept until you get to 3, and that's a set of numbers. If you think of a number line, negative infinity up to 3 is a set of numbers. And then we say 3 has to be excluded, but the numbers past 3 don't have to be excluded. So 3 to infinity, no problem. And the way to join those two sets of numbers is this symbol called union. Right. So that's pretty much interval notation. There's a little more to it, and maybe you'll review it as we go through tonight. So point there is taken, we don't want to divide by 0. Another simple example. What's a g of 0? What's a g of -1? And just for fun, let's say what's a g of 8? So as a brief reminder too, this is collectively just thinking outputs. Why did I use G all of a sudden? Because you have a name, you have a name, she has a name, we all have a name. And this is a different rule. So we name differently. And in this course, we'll see, we want to talk about 2 or 3 functions at the same time. So everyone can't be F, because you'd be like, well, what are you talking about? There's 3 different functions. So now F is just a naming. This is a new function, G of X. So the output is, here's its recipe. What happens when we sub in 0?
You know, 1.
Yeah, mad simple. It's almost, I wouldn't expect this. Oops. G of 0 is the square root of 1, which is 1. What happens when we sub in -1?
0.
We get 0. What happens when we sub in 8?
3.
You get the square root of 9, which is 3. Things you should know. What happens if we sub in -2?
Undefined.
You're on point. Everyone agree? Undefined issue? Let's just make sure we see it. -2 plus 1. This is -1. And if you were thinking, isn't that -1? You may need to reconsider this course. No, this is not -1. All right. Square root of -1 is not a real number. It's imaginary. Who has seen the imaginary unit before? I forgot to mention that's also part of our course. After we go through trigonometry, we put complex numbers, trigonometry, and algebra together. Oh, with exponentials. Insane. But there's a reason why we do that too. So stuff to come. We are not in the I unit. So for until otherwise stated, we just assume until otherwise stated, we only want real numbers. All right. So you might say, well, isn't that I? And the answer is yes, it's I. So you could say, well, -2 pairs with I. Cool. If we allow that, then this would be a function or would be in the domain. But right now, we're only going to deal with real numbers for a good portion of this class. So -2 needs to be excluded. Actually, what else would make that 0? Would -3 make this 0? I mean, what else would make this not real?
Anything below -2.
Anything below -1. Right. So the way to think about that is, what makes this 0? It's kind of like asking ourselves, we should be able to look at this and say, what makes this 0? 3. So that needs to be excluded. Now I'm going to look at this and say, what makes this 0? -1. Not a problem. We're not excluding you. But if I go -2, now I have an issue, or -3. So this idea of something from previous courses called zeros are massively important with functions. Zeros play a lot of roles. We love finding something called zeros. I'll define that another day, but you're going to hear it. We would say the 0 of this function is -1. It's what causes 0. The domain here would be all numbers -1 to infinity. That's it. So nothing less than -1. Everything greater than -1. Last little review for interval notation, and then the rest would be on you. This is a square bracket. That's a like a wave bracket, parentheses. The square bracket allows us to choose -1. And we'll see more of that tonight, right? But it just means -1 is included versus if I put a parenthesis on it, it would not be included. That's the warm-up. that's the stuff that was just to get us going. Here's the pre-cal. A, factor. Well, this comes out of nowhere. Factor 3x cubed minus 8x to the 4. Oops, not fourth. Squared plus 4x. After we do that, we're going to find the domain of f of x equals x squared plus 7 over 3x cubed minus 8x squared plus 4x. And then after that, we'll find the domain of g of x equals the square root of 3x cubed minus 8x squared plus 4x. All right, it's a little more than 5 minutes. Oh, here we go. That's all the stuff we're supposed to know. Now it's time to learn stuff. And actually, some of this stuff we're also supposed to know too. This one we're supposed to know, and I think you should be able to apply that to what I just went over. But I'll do this one with you. And then part of your group work today will look like this. Factoring expressions, a big topic that we're not going to kind of teach individually. I mean, there is a couple lessons here and there where we'll learn advanced factoring techniques, but things like factoring out GCFs, you're supposed to know. You're supposed to know how to factor a GCF. And then the other thing you're supposed to know is what a difference of squares is and how to factor 3 terms, particularly if they have an exponent of 2 into 2 groups of 2. But I'll review this once, a couple times, and you'll have some practice later. All right. Then we're going to see why did we even do that? How is that important for parts B and C here? Well, if it's not automatically obvious, this expression in the denominator is what we're factoring. And this expression right here inside the square root is what we're factoring. So A, factor 3x cubed minus 8x squared plus 4x. What's the greatest common factor in those 3 terms?
X.
X. So we undistribute it. You get 3x squared minus 8x plus 4. Just a reminder, that's a GCF. Now we're going to look at 1, 2, 3 terms called a trinomial. And I'm just going to review the strategy. One strategy is guess and check. Some people can look at some of these and just say, "Oh, I got it. That's pretty great." And actually, when I was in high school, that's what we had to do. But there's a pretty clean algorithm, like set of steps, called the AC method, split the middle method. It has a lot of different names depending on where you went to school, what your teacher calls it. But I'm just going to call it both those things. Like it's the AC method, split the middle. Another thing you can YouTube. Split the middle, YouTube, AC method, YouTube, factoring trinomials. It requires looking at this number and doing a little side work. 3 times 4 is 12. And then you think, or not think, but you find factor pairs of 12 that are going to make the middle term. So I'm just going to do all the work out, but if you can do it in your head, that's cool. So sometimes I just go through this in my head. 1 times 12, does that add to -8? Nope. So then I go down to 2 and 6. Does that add to -8? No, it adds to +8. But if I slap them both with a negative sign, now they add to -8 and they multiply to 12. So we split the middle, 3x squared minus 2x minus 6x plus 4. Now I've taken a trinomial and turned it into 4 terms. From here, we factor out the GCF of the first 2 terms. We factor out the GCF of the second 2 terms. Well, I'll just do that now.
Excuse me, sir.
What's up?
I was looking at the 2 and the 6 just so that you get square. So I kind of like switch it and say 3x squared minus 6x and put the 2 on the other side. I don't know if that is.
If you lead to the same result, you're good, as long as you can get here. And then we'd be left with 3x minus 2 times x minus 2.
Yeah.
That's right.
So if you got that and you have a different way of getting that, you're good, right? If you didn't get that, you're going to practice this redundantly in this course, starting right now. So AC method, split the middle, take the GCF of the first 2, take the GCF of the second 2, which is the number 2, and you have this common, so there's kind of overwhelming amounts of parentheses going on here, but if you look at like the big parentheses and treat that as like, I don't know, its own little neighborhood for a minute, you have a common group, and then your leftover goes there. And now we've factored that polynomial. Part B, what's the domain of what was an issue earlier tonight? Few things, but what was an issue earlier here?
Can't divide by 0.
Can't divide by 0. And looking at this now, this is the division. This is 1 divided by a number if you give me an x. But I hope whatever x you give me doesn't make 0, because that would be a problem. This is 1 divided by eventually a number. What inputs are going to make 0? In that form, I can't tell either. But what we just did was factor. So rewrite in factored form. And we get f of x is 1 over x, 3x minus 2, and x minus 2. And factored form is super simple. It's by inspection. Give me an input that gives a 0 in the denominator. There are 3, by the way. 0. F of 0, we plug in 0 here, we plug in 0 there, we plug in 0 there. I actually don't care what number it makes. I don't care what number it makes because this 0 in front destroys it. So 0 is excluded. What's another excluded number?
2.
2. Because it makes this group 0. Doesn't matter what this is. 0 is going to annihilate those 2. What's the third one?
2/3.
2/3. You should be able to do that in your head. So what makes this 0? Add 2 and divide by 3. Check it. 2/3. The 3's cancel out, and you have 2 minus 2 could be 0. So this is simple math. Add 2, divide by 3, and the answer is 2/3. So x cannot be 0, 2/3, or 2. And in interval notation, let's see, what's the smallest one of these numbers? Actually 0, then 2/3, then 2. I just happen to have it in order. So now I'm thinking I'm on a number line, this imagine, I don't want to use the word imaginary, this make-believe number line, and I'm walking in from negative infinity until I get to 0, I have to exclude it. So in interval notation, negative infinity to 0, union. So it's kind of like hopped over 0. Now I'm walking until I get to 2/3. You jump over 2/3, and then you, oops, my bad. Yep, you're right, to 2. And then we union that with 2 to infinity. That's pretty obnoxious, but if you understand that, you got it. Cool. Let's just cut to the chase. I'm not going to rewrite the unfactored form. I'm stressing, 1, we need to know how to factor. 2, it's a useful tool, at least, even if we don't know why yet, but it's a useful tool for at least finding the domain of these functions. X, 3x minus 2, and x minus 2. What did we learn earlier about square roots? We don't want the inside to be what type of numbers, because we're only dealing with
Negative.
real numbers right now. We don't want negatives. So I was like, yo, if you can find 0, that's not a problem. And that's actually a good thing, because we know a little bit over here, 0 or negative numbers. Everyone over there is going to be cool. This opens up a new can of worms. Give me a 0 of this function. What output 0?
Same one we just had.
Same ones we just had. 0, 2/3, and 2. So if you give me any one of those numbers, they would output 0. That's helpful. I'm going to answer this using a number line. 0, 2/3, and 2. I'm going to give them like a green light. You guys are good to go. You're in the domain. I don't have a problem with you. Everybody else, I have no freaking clue. So let's check. This is what we do. And in Calc 1, you're going to do something called the first derivative test, where you do this. It's literally what is done. If you don't believe me, Google search first derivative test. You have to take a number line and test. There's no fancy schmancy stuff. You figure out what your critical numbers are. You're going to hear that word in Calculus 1, critical numbers, and then you're going to see what's going on around them. Well, we're going to start that right now. What's going around over here? What's the number over here? -1, -2. I like -1. -1, 3 times 2. So what happens when you get -1? What value does that make? And you can use a calculator here. I'm going to give you a minute. What I'd like you to do, so you're not just, if you fell off the bus because I've been talking a while, this is kind of just independent, not group work yet. Sub in -1. Is it an issue? If it's a positive number, we don't have an issue. If it's a negative number, we exclude it. I want you to think about a number you can sub in here. I don't want to say a specific number because it's not going to matter. I want you to test the number in here and test the number in here. You got 2 minutes independently. See what is an issue. And you can definitely use a calculator. I'm going to walk around, pass one of these out. Please don't start this if you finish ahead of time. Do not start this.
I'm gonna start it.
No. 30 more seconds. If you who's got all 4 intervals, like yes or no. Good, pause. Still working. All right, just keep number crunching. If you didn't get to all of it, we will do it together. Why did I do that? It's all good. All right, so if you can just put your eyes up here for a minute. Couple quick things. Desmos, if you haven't used it, I don't know I haven't met anyone who hasn't, but there was a time when actually I met the person who was saying, I was at a math conference at Drexel University, went all on my own on the summer. It was like, I think I talked about Twitter before, and like just met these math teachers, and Twitter was really hot. And so this guy's in front of me, and I was like, oh, like everyone was wicked smart, wicked awesome, wicked into education. And this guy's like, oh yeah. I'm like, what do you do? He's like, I'm a teacher. And he's like, I'm creating this website called Desmos. I literally met the guy who thought about Desmos. He was creating it. So there was a time when people didn't know what Desmos was. And proof is I got pictures and like a lot of cool swag. Well, I guess not cool, but Desmos graphing calculator. So number 1, here's the graph of that thing. We'll review that later. I'm not expecting you to remember everything that you might have seen before. Maybe you've never seen it before, but who cares? There it is. There's the graph of that rule. That's not my goal tonight, at least not right now. My first goal is to say, if I write the factored form in, x, 3x minus 2, x minus 2, man, there's a lot of things to notice. But immediately, I notice that the 2 graphs overlap, therefore they're identical. So it's a way to check my work. It's kind of like a cool way to check my work. If the 2 graphs overlap, they're the same. Another thing to notice is the x-intercepts are these numbers that keep popping up, the zeros. So I'll give this a little zoomy zoom. And there's the zeros, which on that number line, which I'm going to switch back over in a minute, were not a problem. But I asked you to choose a number to the left of 0. And if you use your calculator correctly, you got a negative number. Did anyone find a negative number? Yeah. You probably all use -1, but if you use -1, it's something like negative whatever. I don't care. What did you choose between 0 and 2/3? How many people chose a half? Yeah. And what did you get as an output? I bet you got, let's see, 0.5 is right there. Something like, I can't get there. 0.375. Yeah. You got a positive number, which is above the x-axis. Did anyone choose 0.393? I did. I'm just kidding. But if you did, you would have got a positive number. Bigger idea here. Anything between those zeros is going to be positive. It's above the x-axis. I asked you to choose a number in this interval between 2/3 and 2. How many people chose 1? Did anyone choose something else besides 1? I did. I chose this number right here, 1.951. 915, my bad. And I got negative. No matter what you chose on that interval, it's going to output a negative value. And then anything to the right of 2 is going to be positive. We have a lot more to come back to this here, but that's a cool visual, and it's actually a goal of mine tonight. Using a technology, you know the output, these are called zeros. X-intercepts are zeros because they output zeros. And the parts above the graph, while we might not know their number, we can definitely say they're positive outputs. These are positive outputs, and these are negative outputs. And that's now helpful if I switch back to this. Where did I lose mine? Okay. Is that on? I have no idea. Okay, there we go. We saw that the graph, I forgot what it did already. What did it do? Like something like this, this, and this. You don't even need to know that part of the graph, but my goal for you right now is one, kind of observe that, recognize that, that's cool. Secondly, you can definitely number crunch. You will in calculus, you will with certain number values, but this down here is negative, and we don't want the square root of a negative, so this entire interval needs to be excluded. The numbers in this interval were positive. This is allowed to be positive, so we're good. The numbers in this interval were negative. They're excluded. The numbers greater than 2 were okay. In interval notation, the domain of this function, 0 is our starting check mark number. And we can, we're allowed to use 0. So it's a square bracket until we get to 2/3, which we are allowed to use. So we use a square bracket. Union 2 to infinity. And that's the domain of that function. I'm going to pause the recording at this time. Oh, I can't pause it. That's okay. I can trim it later. So that'll keep running. It is 4:50, and that was a little longer than I wanted to, but all good. Everyone has a sheet of paper with the letter A and a number. Yeah, either A, B, C, D, or E, and then a number either 1, 2, 3, or 4. Today we're going to do this. All the A's you're going to gather right there in like once I'm done talking. I don't know, a minute or 30 seconds. So kind of just go over. And as we continue to meet our classmates, it's always good to like introduce ourselves. I haven't even got to say, I don't know who's who. I don't even know you guys yet. So I want to do that at some point too. But I'm going to try to start doing that today. All the A's are going to be there. All the B's in that corner. We'll do C, D, and E in the back corner. So it's like A, B, C, D, E over there. A, B, C, D, E. Right? Cool. Mingle, work. And now you can start the front side of one training group after you do some quick introductions. Do make them quick, but I would like you to get started. And if you are someone who's like, this is wicked easy, right? Be more of a helper than an answer giver. So be a coach, be a tutor, be a friend, be a classmate, because at some point it's going to flip in this class. You're not going to know everything, right? If you're the one struggling, don't be, it's easier for me to say, but we're all going to struggle at some point. Learn to self-advocate and say, hey, can you help me with this? Or how did you think of that? So A, B, C, D, and then E against that wall. What letter? Good. E's. This should be D. Cool. And these desks are easily movable, which is a pro for this group. So you can kind of act with that. There you go. That looks like a group. That looks like a group. C, back there. And now's also the time, before you even get started with your group, if you need to use the restroom, you wanted to take like a 1-minute walk, I would do that now. Is there any other E? Oh, you got 1, 2, A, B, C. Only 2? Oh.
Yeah, I did. They already do that.
So one strategy might be like you either kind of work the same question at the same time. That's one thing I really promote. Right? Same question, same time, even if you're the one done first. I get it. I've been on both sides where I'm like, oh, this is easy for me right now, but that's okay.
We're just the smallest screen.
I don't know what happened there. I obviously miscounted something.
Well, -4, -1. I think so.
What's everyone's name? What's your name? Jonas?
Yeah.
Dominic.
I think, probably.
Terrence.
And then,
Well, I get it, I guess you could say.
yeah, I think, yeah.
Well, it's been since you guys like.
Good year. Yeah, good year.
Yeah, there's some cobwebs. I know. I get that. That's why it's time for talk about.
And I'll be walking around momentarily when you guys.
Let me just, I'm just doing that, if anything from. Yeah, let me just go through it and make sure it's right and I'll let you.
Yeah. So you do the next step? Okay. So you're gonna take first and the last. So that's 4, right? Now you can, so now you can use stylus. So here, scratch paper, or so number, you might do.
Now we gotta do that.
Now let's start looking for what multiply. 1 is better. Does that add to? Yeah, well, almost, what we have to do is. Yeah, so again. Oh, the quadratic formula? Yeah, see now you can't, like, you have to know what.
Yeah.
So I used to just break it down. So you do it's 2x cubed minus 5x squared plus 2x. And then you do x times 2x squared minus 5x.
Split the first. In our middle term, literally, guys, we're gonna split into. And if you're kind of like, oh, does 4 matter? So -1.
If my math is not.
Yeah, oh, yeah.
-4.
Okay, so pretty much you're trying to find the value of -2 and 5.
Yeah.
So good?
Okay. I always think whenever you I was thinking just take 2 out of 9. Just like
I mean,
go back.
it's a good thing to have. I always like mix it up sometimes. So
Alright, so common factor just means every single.
You just kind of. I like to like split it down.
Oh, so you just split -5 in the middle.
Well, like once you have the two, once you like write the two factors down, then I just kind of like to split it down the middle.
Take it out again.
Common factor of 2x.
Now there's no more X, you took it out.
You know, you're doing it right. Like your second
And now you want the MCF.
You should do it.
It's the same.
Different order, they're still gonna be the same answer. Now,
So
what's
yeah,
Yeah, it could be. I honestly prefer microwaves. For some reason.
and what else? Longer.
Yeah. So the thing that multiplies by 4 or multiplies to 4, right?
Oh.
That makes sense.
Oh, you're okay. You got it, too. Words out there. Yep, you got it. Next term, move of factor 2, like dividing on. I always try to domain range.
Yeah.
So it's 2x.
This is not my strong suit, to be honest.
And then
It's like you're under.
I, interval motivation.
Like, it's like easier with like.
I understand that.
When I first introduced you, like, my mind wanted.
That's usually
Yeah.
the difficult part.
So you just break it down. So after you get negative 4x.
So like, once you get the negative 4x, you get negative.
Oh, yeah, okay, yeah.
Yeah, so then once you write it out, you can just like divide the e's.
If I do it, negative 4 and negative 1, you gotta get that part.
You kind of take these as their own separate.
So.
Two separate things. And then you just factor those out, so like the three.
Now, this side, and then if you want to talk about the negative. Yeah, you gotta factor it out. Yeah, so.
Okay.
I
very last class.
These are the same thing.
I did write it down.
I should have wrote it up, and, like, see what I did here, so I got this in parentheses, and then I factored out 2x to be equal to.
All right. I'm gonna walk around and show you everything. Yeah.
2x divided by that, negative 2x divided by that. And then for this one, I'm gonna make sure we match, that's how you know it, right? So then on this one, I factored out negative
That group,
1.
definitely. So we're all gonna have.
Yeah, but that was really confusing. It shows, that's just the.
We're gonna factor more.
Yeah. Yeah, and then make sure you both the same, right? You have to factor out a negative 1 for this
On your own,
one,
reach out
and
to
then
me.
about negative 1x and x, and then just flip the sign like that. And then you
Doing
want
well,
to get these two, you got that. You just get these two, and then.
This is where I'm gonna explode.
Oh, you're on the second one?
Yeah, I'm kind of.
Negative.
Last part.
So what do you bring us the first one? Yeah, so the last one, you get the two and factor out, and then you put them in parentheses, and these two, everything.
I'm checking the background stuff right now.
Everything under
Yeah.
zero. I was like, and then the x you get something. Got it.
How'd the factoring go?
A little rusty. Most of us, some of us are, some of us not. So
Alright.
you want to definitely kind of look at over the weekend too. Factoring, trying to have a smaller lesson right now.
Yeah, I don't think should have too much.
Like the main problem is gonna be, it's gonna turn the shape of the curve, and everything else you're gonna.
You can take a look and see what
It has to be.
Oh, okay.
You know what I did? I did
A little differently,
Yeah, we did it.
It's not saying
Yeah,
you
that'd
know,
be great.
Fundamentally.
Okay, now.
When I do.
Yeah. About the numbers that matter, so it could be less than one.
Yeah. It should not be zero square root.
Yeah, because
You
if
know
you
that.
put all these
For the next one, I think I'm zero.
So I think that, so I think this is how we learn it. Infinity to 0. And then union, because that's one of the. Yeah, and then the next piece is 0 to 1. Union. And then union.
I mean,
It's like a constant.
Now you're just.
It is.
And then after that,
And that's not even like.
You gotta worry about it.
And this more.
It can't be between that and two.
Yeah. What do you talking
You inherit a cross like
Pencil back, now you focus on these.
Oh, that's.
Yeah, so you get whatever you factor out, and you flip them to the parentheses. It doesn't matter which order you flip them, it could be negative.
So how'd the factoring go for us? That's the number they have checking, and I'll let you know since I'm screwed, it's like a 50%. Some people got it, so I was like, yo, I'm mad about it. So you're probably in one of those categories, right? Who felt, anyone feel wicked strong about it? Factoring? But not,
I'd say like.
coming back to you pretty quickly, all right. If you feel it a little bit, yeah.
So there's more factoring to come tonight, but something you might want to do over the weekend too. is- It's just, there's a lot of cobwebs and a lot of things that I expect you to know, and I get it. Once we get rolling though, that's why I said, we're gonna be playing with fire tonight and this weekend, but if you can persevere and get through it, the rest of the course is gonna just really get going with this.
It doesn't.
My biggest problem is like, I have like,
Maybe,
I don't know, next one I goes around, I completely forget about it. Yep. And I'm figuring out. So
I noticed that.
I don't have all the answers, I really don't, but one thing that has worked for some of my other students is like, once they identify like the mistakes they make, they either go to like the last page of the notebook and say, this is something I did, and like, I know I'm not gonna do it again, but they make like a checklist for themselves, and they say, like, don't do this, like, note to self. This is something I know I do, most people don't do it, but I always rate 13 to 31, so whenever time I see 1 and 3, I need to slow down, that might be helpful.
I didn't know if it was, important.
So.
Are you guys getting that
with,
just that, or like? Yeah, correct.
So are you having issue finding what the number, like, what the domain is, or writing out the actual domain? Yeah, so if we go over here, so if I plug in the question, let's plug in 0, give me 0. Okay, yeah, let me just restart. So first of all, division, you can never divide by 0, or it'll be undefined. It's not value, right? So what we want to do, we want to find what we plug into here that will lead us to divide by 0, which is undefined. So this thing, when it's factored out and it gives us this equation, and if I plug in 0 into here, it's going to give me 0. And that means undefined, 0 to me, and then I have to plug in 2.
Minus 2, okay, I'm looking at plus. Okay.
It's gonna, you know what I'm saying? And then, you know how to write that?
Yeah. This is where it's positive.
Yeah,
This is where
yeah,
it's
so
positive.
if you need some tips, just let me know. Just make sure you don't get the correct zero in the brackets. That can be kind of
I'm looking at yours. Okay.
So 1 is over, you said 1.
Yeah, 0 and 1.
Yeah, I have right here. I have both the factors, so you have and the original. And there's, so they go up
That's what
there.
I got.
Oh, there's a great.
Oh, 1 is it?
Oh, yeah, that's right. So,
pretty much
since there's not real numbers,
you plug in here,
it's only gonna be positive.
I got a 0 too.
Yeah, that's kind of cool. I need to. Hey, check what I actually did. Maybe you're on there. So it is only because of one. You guys really very, very good. We're gonna have to share that out with everyone, and then we'll discuss. You actually, I didn't tell you. That's a good idea.
No, you. So if it's
7 minutes. It's okay if we don't finish them all. My my goal is 1 and 2. We're having awesome conversations, reviewing generalization, factoring. They took it a little different way, so very, very good. Don't rush good conversations. But it's, what I'm expecting is like, if you can get through 2, awesome.
Yeah, I was wondering.
So.
Are you supposed to just? That's what I see. That's
I thought it
This is also.
Yeah.
So basically, the thing is, you don't want to take 0. So at any point, if any of these equal 0, you multiply any number 0. So
Can I choose?
basically, you can go through.
Can I choose everything else?
What would make this equal 0?
So
And this equals 0.
you can't choose 7. That's a division. Infinity symbols. So you're trying not to make it. Here's
You're trying to make
problematic
it
number.
just so you can like see
Oh,
what not to do. You know what I mean?
Because
what
you
doesn't.
cannot use it.
Yeah.
But
Oh.
you're
I was
inputting.
thinking because.
You're all good. Alright. Well, okay, so this equation is the same as this function. Can I
It's
input
the same
7?
thing.
Okay. 7 minus 7 makes What's the square root of 0? Wishes. So 7 is allowable. Can I put 8?
No, you have a minimum. Yeah, so. Well, you wanna find
So
the least
we have evidence that we
There's
can
never
never
like
get all, including 7.
Yeah.
Can I do 6? 6 minus 7, -1. No. Now we have evidence we can't increase the numbers on this side. Okay, but to answer your question, 7 was interesting in both these problems, but it wasn't even allowed to be used here. This one, it is allowed. Always parentheses.
You do the one, so, yeah, I don't know, like, I'm just like,
I don't believe
Yeah,
that.
0.5.
How did you establish that?
You gotta teach me.
I don't know how to get back to my regular schedule.
I don't know if you
The idea is, I'm gonna go back here. Use our tab.
So I.
Oh, my bad. I thought it was, no, you're good. You're good. You're good. You're good. My bad. I thought it was going underneath. My bad.
Yeah.
Yep. You're not allowed to use it.
Yeah, but then
Yeah, even though you, yep, you put the positive.
Thank you, sir.
Yes.
I'm not. So.
I mean, actually, yeah.
So we are doing that. You can all agree.
Zero works.
Yeah, you just use 0.
Wait, no,
Zero.
so
Okay, thank you.
so we're not getting to zero.
Yeah. Talk to him. That's such a weird.
No, actually, I think sense.
I'm not sure. Is there an asymptote? I'm not. Some people.
I'm showing zero.
I think I'm sure answer, but let's just ask.
Yeah,
actually, I think there is what
I'm a video person. Okay, that's it. It's a way to see.
All right, there's a lull in the room, so I'm gonna take it. I don't think I'm quite at my 7 minutes, but if I can get all eyes on board, even if you can get through all questions. So I pretty much touched base with every group. I did touch base with every group and shared this, but so we're at a point. One thing that I knew was going to happen. This isn't a surprise to me. I knew I was going to throw it at you quick. I warned you at about an hour ago. Said we're going to play with fire pretty quickly. And some of us are like okay to good with factoring, and so they're not super concerned. Some of us are like, uh-oh, I got cobwebs. I'm rusty. Listen, you have the prerequisites for this course. Do you have the prerequisites to just step it up right now? Get into that growth mindset that I brought up before. I mean, seriously, don't wait. Do not wait. The rest of this course is not that bad. I told you a lot of scary things, but right now is just getting yourself motivated and get these skills out of the way, like the factoring skill, in addition to the homework, right? So sometimes you have to do a little bit more than somebody else. And that's what mathematics can teach us in addition to actual math. Like, do you have that driving force? You're in the right class because you have the prereqs. What am I trying to say in a nutshell? If you need to review factoring, I told you the key phrases and I'll send it out on Blackboard too. But factoring trinomials, splitting the method, split the middle. Find a TikTok, it's around for a little bit, but a TikTok reel. It doesn't have to be a 20-minute video. When I watch YouTube videos, I filter them by under 4 minutes. And I want the quick, just show me how to do it. And there'll be plenty out there for you, right? So I just want, if you're in that boat, you're not alone. My quick survey is literally 50-50. Some of us are like, oh, I'm really great. And then some of us said, I'm good, or, I'm okay. I think I'm okay. So if you're in the bottom 50, you got a little more to do, but you're not in the wrong course. I don't want you to be like, I'm out of here. Next thing.
I'm going to work out this example. So here we go. Probably take 5 minutes. I'm going to do a couple more. We're going to stay where we are. And then you're going to get back into new groups, right? So we're going to pair you by the numbers in a few more minutes. And that's it for today, all right? 2x cubed minus 5x squared plus 2x. So the x is common in all these terms, right? So greatest common factor. Those are usually the easiest. The next one is this middle group here, 2x squared minus 5x plus 2, called your trinomial. And the strategy, the AC, so we call this ABC. You've all used the quadratic formula before. That's where the A, B, and C are. So you take A times C, and if you can do it in your head, cool. If not, you do a little side work, or this is what scrap paper's for. This is stuff you do on scrap. You don't want to mess you up over here. But I'm showing you what's going on in my brain. I'm thinking 1 times 4, 2 times 2. Oh, wait a minute. -1 and -4 did the trick. So split the middle. Don't forget your variable x. And now I'm going to pay super attention just to that. What is the common factor of these two terms? It ends up being x. And if we undistribute an x, you get 2x minus 1. I'm going to look at these two terms. And now you ask yourself, what's the GCF of these two terms? 2. There's no x. So not x, but the number 2 is a factor of both those. You always take the leading sign. Since this is leading negative, all together, we're going to factor out a -2. And so this will become a group of dividing by -2 and dividing by -2. And now when I step back out here and just look here for a minute, I know my work is correct every single time when those two groups are the same. So you write it once, and then you put those remaining factors in its group, and then don't forget your original x. And maybe you watch this video again. Maybe that was helpful for you, right? Practice, and that's just the algorithm. That's it, right? You have to be able to factor. It does not go away at all. And it's not going to go away in calculus and beyond. There's the factored form of that. That group back there checked their work. How did they check their work? They're not allowed to answer. How did they check their work? Not by asking me. What did they do?
Check with each other.
Yep. And what else did they do to guarantee besides with themselves?
Take that and then re-multiply back in. See
Oh,
if it was
that-
something.
That would be pretty smart. So if they expanded this ball back out, like foiling it back out, you should get back to the beginning. No, they didn't do that, but that would work. Nice conversation. What did they do? What did you guys do? You can answer now. How did you know how did you know you were good?
Oh, I put it into this.
So they took something from the lesson and now they just checked their work on their own. And I thought that was interesting. I was like, oh, cool. Good way to check your work. But everything you guys said so far was good. If we check Desmos, I want to be respectful of time, but I'm just going to type in the factored form and get to what's interesting. Okay. That's not the factored form, is it? Was that the last? Did I do the same? No. That's it, right? So I don't know why it didn't show up on your phone. Oh, because did you put it in the square root?
Yeah, it only shows the positive value.
Okay, so here's the factor form. Boom, we see the zeros. Right. One thing they did was they actually put it in the square root. So if I copy all this, oops, that stinks. I type in square root of that. They were like, we're not seeing anything else, but they are seeing the outputs right here and there. And literally, this is a visual of like, hey, I said we only include domain values that actually have an output. So there's no graph over here. We can definitely see a graph over here, which are the numbers between 0 and 1/2, all right? And then there's like this big break in the graph. Now, that's not the conversation I shared in class. What I shared was if we look at just this, just these factors, notice everywhere.
You put an X plus X minus 3.
Okay, that was like, notice that this is not what I wanted at all.
The shape's not the same because it's not the same rule, but the domain, where is this below the x-axis? Less than 0. Where is this below the x-axis? Between 1/2 and 2. So if I'm losing you, I just thought this was a nice connection. I don't necessarily want to say do that. By the way, you don't have access to Desmos on a test or quiz, but there is a first assessment question or a final exam question where you just should look at a graph and be able to state different things. So if I said, here's this thing's graph, you can be able to say, well, where is it negative? Boom. Where is it negative? Boom. Where is it positive? Up here. Where is it 0? Well, those are the x-intercepts. That's one thing you should be able to do. And that's important, at least for this reasoning, when we're asked to find, like, hey, what's the domain of 1 over 2x cubed minus 5x squared plus 2x? Well, we wanted to look at, one, we can do it analytically, paper and pencil, by factoring and say, where are those things going to be 0, which are 0, 1/2, and 2, which I saw across the room. And so, by the way, really quickly, we would say negative infinity to 0, 0 to 1/2, 1/2 to 2, and 2 to infinity. Right. We don't want to divide by 0. We can see those are the zeros. 1 without a graph, but also with the graph. Like, multiple things tonight, like a lot of different ways to think about these. But the real goal, like paper and like assessment purposes, you're supposed to be able to take this and say, all right, those are the zeros, and I don't want to make a 0 down here. Additionally, if we had the square root of that function, we can say, all right, we know these are the zeros. And then you got some testing to do. Now you can plug in the number back into the factors. If it's negative, well, with square roots, we don't want that interval. But if it's positive, we do want that interval. If it's negative, we don't want that interval. But if it's positive, we do want that interval. And that's the goal. And there's also connection to calculus. I already mentioned that first. Just saying you're going to do this again. So test numbers on intervals, and that would be our domain. So the domain of this would be 0, 1/2 union 2 to infinity. Some of us asked, what can you just quickly remind me why I'm using square brackets versus closed brackets? I'll happily do that after class if you still have that question. I was able to answer it to some groups, but it won't take long, and that's something that I can answer after this brief here. Number 2, there was something that looked like this. This is when x is -2. This is where x is 3. Part A says, what x values make 0? So now I'm assessing. Given a graph, where are the zeros? What inputs make 0? What input would have a value that outputs 0? Yeah. X-intercepts. Even though we don't have the recipe like earlier where we were actually plugging in numbers and number crunching, we have a graph. That is a goal of mine tonight. You're supposed to know from a graph, even if you don't know its rule, -2 outputs a 0. Literally, think of that ordered pair. -2 pairs with 0, and 3 pairs with 0. So your answers for that are -2 and 3. B, where is the function greater than 0? Well, it's 0 right here. In between, when it's above the x-axis, it's greater than actually all of this. Now, is it greater than 0 right at 3? No, it's 0. And this is a strict inequality on the paper. So we would say from -2 to 3, 3 to infinity. Emphasizing that one more time, because it's above the x-axis in between those two numbers, and on this, but at those endpoints, it's
on the x-axis. That 0 is not a positive number. So we can't include it this time. If it was a inequality that allowed it to be equal to, we would have included it. And that would have changed those to square brackets. Part C. What's the domain of x squared minus 5 over h of x? Interesting question. Very symbolically crazy. Do we care what number is on top of a fraction? No, we don't want to divide by 0. In part A, we said this is 0 when x is -2 and 3. So the domain of this function is negative infinity to -2, union -2 to 3, union 3 to infinity. I'll say that one more time. This is division. We don't care about the top. That was a distractor. We don't want this to be 0. Bro. When is that 0? Right here. So we need to exclude -2 and 3. Don't include it. Don't include it. How about square root of that function? Well, it has to be 0 or positive. Outputs 0 or positive. So I think we were good starting at -2 forever. The domain of this was -2 forever. Any groups get all that? If you didn't get it, who's somewhat getting it, kind of warming up to it, and you can come back to this video after. We have about 15 minutes. So where you're at, flip over that paper. You're going to do those questions in a minute, but I'm going to give you some warm-ups here. But just look at them. And as we're about to say farewell to the group you're in, think about letter A. Think about letter A. Where should our focus be if I'm concerned with figuring out the domain? Denominator. So as you say goodbye to your group, solve letter A together. Factor the denominator and find the zeros of it. Pretty simple. I think it's not a split the middle. Factor that. What are the two zeros? And this is your farewell.
Well, we're not even factoring. To find the domain.
Good conversation over there. For the domain, we don't have to factor the top because we're only caring about dividing by 0. We don't want the bottom to be 0. How does the denominator factor into what? What's common? If you want to distribute x, what's left over? What makes this 0? What number would make that 0? What number would make this 0? So if you were to sub in 0, it would make 0. It needs to be excluded. If you were to sub in 6, it would make 0. It needs to be excluded. Our domain is lost here. Negative infinity to 0, 0 to 6, 6 to infinity. If you have a number 1 on the front side of your paper next to your letter,
You're gonna be here in a minute, and this is our last move for tonight. We don't always do 2 moves, but again, it's early in the semester, I want you to see as many faces as possible. 2s are gonna meet right there, 3s and 4s. There's no 5s, so some of these groups might get a little bit bigger. And before I let you go, when you get into your groups, reintroduce yourselves. Hi, I'm this and this, but keep it going because we don't have much time left. And here's what I want you to do with your new group. Before we attack letter B, I want you to count how many divisions you see in that problem. How many divisions do you see in total? All right, 1, 2, 3, 4.
Now we're going with our group. Now. Well, mine's.
So your number.
So now you're staying in the jail.
Oh, I'm staying in this one.
Oh, I got
Cool. Let me see the other side.
Yeah, because I have to see it. I love your bag, by the way. Thank you.
Oh. What's up? 1, 2, 3, 4. I have to make the groups a little bit bigger because it's, you might have to spread out a tiny bit. 4s are over here. Say hello, go around, introduce your name, and then count how many total divisions you see in this example. You don't have to proceed. We're going to kind of do this together. No, just right now you're going to go letter B. How many divisions you see?
I'm Alex.
My name's Gennaro.
In total? There's 3. Scary.
You don't have to answer it. Just answer this question. How many divisions are? I'm hearing the correct number.
Okay,
How many divisions are in there? How many divisions do you see? Technically 3. All right. Then you see it. What's the first division? Right here. This right here there's a division. 2 divided by eventually a number. So that's a division. This can't be 0. So X can't be 1. There we go. Exclude it. Okay, where's the next division? The next almost obvious one. Yeah, 9 over X. So again, this ultimately is going to form a number. We hope. Otherwise, it needs to be excluded. But this part right here, this little Lego piece. 9 divided by a number. Uh-oh, we don't want to divide by 0. So what needs to be excluded here? 0. And there is a third division. This is top divided by bottom, informally. So this is a number divided by eventually a number. So all of this can't be 0. Do you see it? I'm not asking you to get the answer here. We're not there yet. But you need to be able to say 1 division there, 1 division there, and then collectively, this is a division. This collection of objects cannot be 0. Take 60 seconds. If you get it wrong, you get it wrong. Try to solve that equation. If you get it wrong, you get it wrong. there are two numbers that will make that 0. You can guess and check, but I would also say try algebra. Try algebra.
0, -3, 3.
Yeah, it would be both.
Nine minus 9/9 would just be.
30 more seconds. Try algebra. Guess and check is a strategy, no doubt. But I want to gear us towards the algebra itself.
Get to the equation, 9 equals x squared, so it can't be whatever equals.
When there is one.
It can't be 3, it can't be negative 3, because both of them multiplied by themselves is 9. How did you get to x? How did you get to that? So like, you have 0 equals 9/x, right, okay, minus x. And then you push x to the other side, so you get x. Oh, and then you negative 9/x. Okay, multiply. Yeah, I was almost there, I just read.
All right, who's got an idea to solve this using algebra, not guess and check? Any algebra strategies?
If you like take the x over the other side, and then you multiply by x, you get 9 equals x squared.
So you want me to subtract this on both sides?
Yeah.
Okay, so strategy number 1, let's subtract x on both sides. So you get negative 9x chilling on the left. Negative x would go to the right. All I'm doing is subtracting x on both sides. Actually, not me. That was this idea. Then what do?
You multiply by x, multiply both sides.
So you could cross multiply at this point. When you have a fraction, treat this like an equal to, even though we're just saying it's like not equal to, but just treat it like an equal to, all right? So if you think about this as being over 1, you could cross multiply now. You can cross multiply fractions. Fraction equal fraction. Be careful with that. But this would be 9 equals x squared. I'm just going to write it in this order. And algebra, well, undoes an exponent of 2, a square root. Just remember, when you're taking a square root algebraically, you gain a plus and minus 3. And let's just check that quickly. Sub in 3, sub in 3. What's 9 divided by 3? 3 minus 3 would be 0. We don't want to make 0, so that needs to be excluded. And if we sub in negative 3, well, that term becomes positive 3. But then this would be a negative 3, so altogether we still would get a 0. So in the grand scheme of things, in this big fraction, to hear me out, you put a 3 here, no issue. Put a 3 here, no issue there. Put a 3 here, no issue until you combine this, and then you'd have a number divided by a collection that made a 0. That's how we see that. All right, so that's strategy number 1. Bring one term over, cross multiply. Is there another strategy out there? There is. I'm curious. Anyone think of a strategy? So going back to this, so the idea was to subtract x. Here's a new idea. How do I take this equation and do a different set of legal moves? Multiply by x right now.
Yeah.
Multiply everything by x. So if we multiply the left-hand side of this by x and we distribute it, we get what right here? What would this become? 9. Idea, multiply by x. So we'd get x squared minus 9 can't be 0. What can we do with this? One thing we could do, actually, we're back at this point, right? We're back to like, yo, x squared, it's almost like x squared equals 9. Although you said something that I also want to review. Does this factor? We talked about GCF factoring tonight. Trinomials. Difference of squares. You can factor a perfect square minus a perfect square into x minus 3, x plus 3. And then by inspection, what makes this 0? 3. What makes this 0? Negative 3. Leaving you with a lot tonight. Again, this is I want you to, and I don't want you to. I want you to feel pressure tonight. I seriously do. Because I want to see who's going to stick around, do the work. Because if you get over this first hump, we're going to learn a lot of stuff. But this is going to be one of the worst weeks. And that's what I want to find out. Who's going to stick around and do it? I hope everyone does. All right. I'm not completely done. Let's skip interval notation for a second. Because we would just say, we found them all, right? We would just put this in interval notation. Are you guys, you understand what I'm saying? We actually did the grunt work at this point. We just say, all right, can't be 1, can't be 0, can't be 3 or -3. And we'd have this friggin' run-on expression. But that's now, I hope, tedious. All right, we have 90-ish seconds. We'll get letter C independently for 15 seconds. No talking. I don't need to be rude, but just 15 seconds of quick thinking. There's a lot going on there. In the next minute, share out your thoughts together. And I'm going to tell you right now, I'm not going to give you an answer right here. It'll be included in the email. I'll write up the solution after, and you can read it later. But talk amongst yourselves. This is the end of our course after you spend another minute, because we still have a minute, about your ideas, what you're thinking, and I want you to try something. Mathematics isn't always about getting the right answer the first time. It's about persevering, not being afraid to not know everything, to take risks, to collaborate, and to independently think and come back to it. I'll see you next Tuesday. You have homework in my lab, but I'll also send out an announcement on Blackboard. Just give me, like 5 tomorrow morning, but I will mean for tonight.
Don't worry
So,
about it.
I haven't eaten yet, so I'll see you guys on Tuesday. If anyone's sticking around after, you're free to go after you had a discussion.
I used to play some game, Fireboy with Water Girl, when I was like 5. Reminds me, I like it.
Yeah.
What? Yeah, exactly. I used to play that all throughout.
I played that so much.
You did
Oh,
too.
yeah.
I forgot about it.